8.2 Linear equations. Expanding a bracket will usually be the first step when solving an equation like this one. 4 times a bracket x plus 3 close bracket equals 20. Okay, so in 8.1 first we looked at expanding, and that's because to solve linear equations we have to use that process sometimes to get to the solution. Let's look at example 1. Solve 5 times bracket x minus 3 close bracket equals 35. Okay, so what we're saying is we want to find out what value for x makes this statement true. 5 times something minus 3 equals 35. Okay, and maybe we could actually figure this out by trial and error, but we're going to use algebra, expand, and get the solution. So 5 times x, and 5 also multiplies out by negative 3. So 5 times x is 5x. 5 times negative 3 is negative 15. And that equals 35. So now at this point, we want to isolate x, put the variable on the left side, and put all the numbers on the right side. Okay? So there's 2 common ways to do this, and we'll look at both. So we don't want negative 15 over here. We want just x's over here. So to get rid of negative 15, we could add 15. Now, if we add 15 to the left side, we also need to add 15 to the right side. Okay, so negative 15 plus 15, well, that gives us 0, and that was the whole point of doing that. And if we do it here, if we add 15 here, we have to also add 15 here. So now we can rewrite 5x minus 15 plus 15, so that just leaves us 5x on the left side. On the right side, we have 35 plus 15, and that's 50. Okay, that's one way of doing it. I'm going to actually delete that and also do it a second way. Either way is fine with me. I'm just not sure which way you will already know or already be familiar with. So another way to look at this is the number on the left side is negative 15. And so we don't want this on the left side. We want to have only x over on this side and only numbers only on the right side. Okay, so negative 15 on the left side, well, we can put it on the right side by simply flipping the sign. Okay, so negative 15 on the left side will be positive 15 on the right side. Okay, so that would mean that on the left side we have 5x. That equals 35. And the negative 15 becomes positive 15. Okay, because we're flipping the sides, putting it to the other side. So 5x equals 35 plus 15, and that gives us 50. Okay, so both methods give us the same result. Just depends which one you're more comfortable with, which one makes sense to you. And now we need to solve. So we don't want 5x, we want to find out what is x. Well, if we divide 5x by 5, then we have just x, because 5 divided by 5, of course, is 1, and 1 times x is x. If we divide the left side by 5, we have to also divide the right side by 5. Whatever we do to one side, we have to do to the other. So on this side, 5 divided by 5, those are gone, so we're left with x, and 50 divided by 5 is 10. So we get a solution of x equals 10. Now with linear equations, we can check to see if the answer that we found is correct, if it actually works with this equation. So 5 times, we're saying x is 10. So here, we're going to put in our solution of 10, and then write out the rest. Negative 3 equals 35. So we want to check and make sure that this does in fact work. We're going to use BEDMAS here. Okay, so we're going to do inside the brackets first. So 5 times, here we have 10 minus 3, that will give us 7. Okay. And 5 times 7 is indeed 35. 35 equals 35, of course. And so yes, our answer of x equals 10 is the solution to this linear equation. Example 2. Solve 6 times bracket x plus 7 close bracket equals 50. So again, first we will expand. So 6 times x gives us 6x, and 6 times 7 gives us plus 42. And that equals 50. So 6x plus 42 equals 50. So here's where you can use either method that you're more comfortable with. I'm just going to go ahead and use the second one that I showed. This is positive 42, but I want to put it on the other side because I only want x's on the left side. So to get rid of this positive 42, I'm just going to move it over here and make it negative 42. So I'll get 6x equals 50 minus 42. Now 50 minus 42 is 8. So I've got 6x equals 8. Now, I only want x, right? I want to get the solution for x. So I can divide this side by 6. 6 divided by 6 will just get rid of that and leave me with x. If I do that to the left side, I also need to divide the right side by 6. So that leaves us with x equals 8 over 6. We can simplify that fraction. 8 divided by 6. We can divide 8 by 2 to give us 4. We can divide 6 by 2 to give us 3. 4 over 3 would be the answer. Now, if we're given decimals in the linear equation to begin with, in the question, then I would expect decimals in the answer. 4 divided by 3 is 1.3333 repeating, or 1.3 with a nice little dot on top. Okay. If we're not, then you can leave it. If we're not given decimals to begin with, then you can leave it as a fraction. Simplified, of course. Okay. So 4 over 3 is the answer. We wouldn't leave it as 8 over 6. Example 3. Now we're getting into some word problems where you did take these words and turn them into an algebraic equation. Gilda thinks of a number and adds it to 7. She then multiplies her answer by 4 and gets 64. So part A, write down an equation that can be used to calculate the number with which Gilda started. Okay, so this is the difficult part, trying to take these words and turn them into a mathematical equation. Gilda thinks of a number. Okay, so I'm just going to say that well, I'm going to use x because we used it for the first two examples. So let's say that x is a number, okay? The number that Gilda thinks of. So it's just x is a placeholder for this value that she's thinking of, and we don't know what it is yet. Okay, so she thinks of a number and adds 7 to it. Okay, so how do we add 7 to her number? Well, we take x plus 7, right? We're adding 7 to the number that she originally thought of. And she then multiplies her answer by 4 and gets 64. Okay, so she takes, her answer would be what she's thinking of plus 7. She wants to multiply that by 4. So here's her answer, and we're going to multiply this by 4. Okay, so that means 4 times bracket x plus 7 bracket. All right, we're taking her answer, multiplying it by 4, and we'll get, or she'll get, 64. So part B is solve your equation to give the number. And we're going to do the same as the previous two. First we're going to expand, so 4 times x is 4x, and 4 times 7 is 28. And that equals 64. Okay, we don't want this 28 on this side. We don't want numbers on the left side. So we're going to move it over there and make it negative. So 4x equals 64 negative 28. Alright, 64 negative 28 is 36. And now we want x, not 4x, so if we divide by 4, we'll get 1x, or x. 36 divided by 4 is 9. So Gilda gets a solution of 9. Or, sorry, we get a solution of 9 for Gilda's number. And we can go back in and check to make sure that this actually works. We can put it back into our equation here to make sure that it makes sense and it works there. We can also go back into our word problem and then see if this works. So let's try that. Gilda thinks of a number. Okay, well, Gilda thinks of 9. Gilda thinks of 9. She adds 7 to it. Okay, so we add 7 to Gilda's number. 9 plus 7. Well, that's 16. Okay, 9 plus 7 equals 16. All right, so far she has 16. She then multiplies her answer by 4. Okay, so we take 16 and we multiply that by 4. And 16 times 4 is 64. And get 64. Okay, so we get 64, and we can confirm, indeed, that our solution is correct. So her number that she was thinking of is 9.